Hi there, Karen Greenhouse here, and this is today's version of Mini Math Lessons. Today we're doing some Algebra II focused content. These are two activities that have to do with absolute value. There's some tangent of theta formulas. There's some circle and ellipse formulas. So it's basically using applications, problems, real world problems, and applying those types of formulas. So I'm using Classpad.net as I have been in the past mini lessons. Free web-based dynamic math software, so you can do calculations, graphing, geometry, statistics, financial sequences, lots of things, all in one place. So you don't have to go to different tabs. So if you don't have an account already, I would suggest you get one, because if you have one, then any work that you do in these activities are free. You don't have to have an account, but if you want to save anything you do, having an account lets you save it so that it knows where to go. So if you don't have an account, here's the landing page. Scroll down, create an account here, and you're good to go. If you don't want to create an account, then just go to the activities, which are linked in the description of this video. So the first activity is about where to set a spotlight in an art gallery, basically. And so there's some descriptions of, the room, of where everything is. And, if we're looking at this, it's in a room that's 20 feet wide. It's got a 12-foot wall, high wall. The bottom of the painting is where the spotlight's hitting, and then there's a top of the painting. And basically what they're being asked to do is to find what is the angle we need to set the light at if these are the parameters that we want. So here's where Classpad has a nice ability to add pictures in. So we've added a simulation of a picture. This is just a little art picture. You can zoom in if you want to see it a little bit bigger. Let me make sure I'm in Zoom. You can zoom in if you want so you can see it better, but you don't have to. Or zoom out, I guess. But basically what I've done, you'll notice, is I've added a grid. And the grid, and I'm going to zoom back out because I liked my grid a little bit better. The grid is to help me kind of visualize what's actually happening. So I've created the room, and here's the painting, and I've made the bottom of the painting be what it says here, 5 feet from the floor. So here's the bottom of the painting. If you look up on my grid, I'm using each little grid to represent a foot. So adding a grid sometimes is a great way to help students visualize what's actually happening in a problem. Get them to draw a picture first so that they really know what's going on. And in Classpad, anytime you want to add things to graphs, geometry, graphing, you go to the 3 dots up here, and here is where I turned on those grids and the axes and the numbers to help me visualize what's going on. So then I connected the light, which notice the light is 12 feet at the top of the floor, and I basically made a segment from the light to the top and from the light to the bottom. And so now I can use this information to help me understand why is it I need to find the slope. We're actually going towards this formula here, the tangent of theta, the angle I'm looking for. What's this angle I need to set the light at so that it does both of these things? And so you'll notice in that formula, I need the slope of those two lines, the slope of the light from the top and the slope of the light to the bottom. So that's why a visualization helps me really figure out what's going on. And so then you can use your calculator tool, just pull out a calculator tool and actually kind of use your coordinates to help you. And here's where the template's really nice. I know that I'm going to be working with slopes. So if I want to try to find the slope of the top, I need the coordinates of the light, which we know the light is always at the same position. It's 12 feet off the floor, so it's at 0 and 12. And then the top, and this is where the coordinate grid's really coming in handy. This is at 20 and 8. So I can find my slope by the coordinates of the light are, the y coordinate is 12, and the y coordinate of the top here was 8, and the x coordinate, so I'm just using the slope formula right now, was, for the bottom is 5. So we're going to put 5 there. So now when I hit execute or enter, I get my slope here, which if we put it in decimal form is 0.8. Okay, so I have my, this is the coordinates of my light, and these are the coordinates of my painting at those different, oh, I think I did that wrong, didn't I? Because I was still on the top. I didn't mean to use the bottom here. So let's go back. Nice thing is if you make a mistake, those coordinates were 20, right? Yeah, there we go, 20. That changes things a bit. So there's my slope. So my slope for this first one is negative 0.2, 2/10, a negative 2/10. Or, yeah. So I now have that, and I can go do the same process. And once I find the slope of both, then I can plug in again for this formula here. Let's do the slope of that second line. So it was the light still in the same position, but the bottom was at 5, and the light was still at position 0 for the x-coordinate and 20 for the x-coordinate in the bottom. So here are my two slopes, and now I'm going to use these two to use this formula. And so this is where, again, we have this absolute value, and that's a template right here. So that's the nice thing about this. We have these lovely templates. So there's my absolute value. I'm going to get my fraction again, and I want to subtract the two slopes. So negative 0.35 minus negative 0.2, and then 1 minus, and we want to use parentheses here, those two slopes multiplied by each other. So let's do that. Oops. Negative 0.2. And then when I hit execute, we should now have the angle. And notice it's in standard form, but we want the angle, and it's, did I do that right? Oh, I have, again, I keep making mistakes. I need to make sure I'm paying attention. So let's just redo that, because I didn't do that right. I didn't think that angle was right. And there is our angle, which is about 14 degrees is the angle that we need to set it at. So that's the first activity, and it just, they're going to do something similar here with a statue. Where should the light be? What's the angle that I need to set that light out there so that those two things happen, and then they get to draw their own image. The second activity, we're actually working with circle equations and ellipse equations, and so radical, and they're going to be graphing them. And here's again where we've got an image to help us visualize what's going on. So this is basically talking about a tunnel that's in the shape of a semicircle. And this is the rectangular area where cars actually enter, and they're going to be working on what's the perimeter, what's the area, and it's using these equations to help us figure out these numerical values. So what we're going to do is, the nice thing is, it's on a geometry sticky. I can actually, the first question is, what's the equation? So this is a circle. The equation is going to be the circle, right? So if I look here, I need the radius of the circle. Well, the radius of the circle is from the center out, which we have here as 15, 0. So we know that that radius must be 15. So what if I want to see what this looks like? I'm looking at the equation here. I can pull up a equation sticky, a graphing sticky, I should say, and try to make an equation that matches this situation, right? So I know that it's the equation of a circle, but I only want half the circle. So which half of the circle, do I have? So here's the equation, 15. The radius is 15 squared. Here's the equation. But then I want to think about, I only want the top half of it. So that means I really only want range values from 0 to, well, what is this? 0 to 15 up here. So I'm going to limit my range. And to do that, I'm using this straight up arc, because that basically says, okay, this is the equation, but I only want to see these certain values. And we're going to be limiting y. So we want y to be between 0 and notice I'm flipping back and forth, and positive 15, right? We don't need to see the negative value. So when I hit execute, watch what happens. I should only see half my circle. Now I don't see any of my circle because of my current window. So I'm going to just zoom in a bit here so we can actually see it. And there is the situation that matches this tunnel. And so now I can start exploring different things with the image. So that is part of this. I could have done this on geometry as well, but I just pulled up a separate graph just to kind of show them next to each other instead of on top of each other. So they're going to be working with these equations, using these equations to help find area, perimeter. So they're going to have to use some radical expressions, and they've got some more graphing to do here. As they scroll down, notice now we have an ellipse, and so now we're going to use the elliptical equation, the equation for an ellipse, and that will help them answer these questions here in the extension. So lots of application of radical equations and working with those. So have fun.